Welcome to Living Well with MS. This podcast comes to you from Overcoming MS, the world's leading multiple sclerosis healthy lifestyle charity, which helps people live a full and healthy life through the Overcoming MS program. We interview a range of experts and people with multiple sclerosis. Please remember, all opinions expressed are their own. If you were able to, we would be grateful if you could donate to help support the podcast and other work of Overcoming MS to help give hope to those impacted by multiple sclerosis. And now here's your host, Jeff Alex.
Welcome to the latest episode of Living Well with MS, and I'm very glad to have joining me on this episode, Professor Richard Burt. Professor Burt is probably, well, no, not probably, definitely the most accomplished scholar and person of any type that we've had on this podcast. He's a Fulbright scholar. I'm going to read this all out because I'll miss things otherwise. Fulbright scholar, professor of medicine at Scripps, professor at Northwestern University, the CEO of Janani, I believe. I think I got that correct. Yeah. He is the pioneer in the field of HSCT. What else have we got? He's the America's first use of HSCT for MS, amongst many other things, including lupus, Crohn's disease. He led the world's first randomized trials for HSC for MS, for Scleroderma. I think it's correct. Scleroderma. And I think the last point, which I was going to try and get this absolutely correct, is particularly impressive, which is having to turn over my page, which is in the Scientific American Journal. He was listed as one of the top 50 individuals in the world in improving humanity. So no caveats, not in MS, not in medicine, but literally one of the top 50 individuals in the entire world in improving humanity, alongside people like Bill Gates. There's a list of people that are very familiar. So an incredible bio compared to everyone we've had. And I would very much like to welcome Richard Burt to the podcast.
Thank you very much.
So that was a brief bio because you were giving me a longer list. I thought it might take up the entire thing because you do have an incredible list of accomplishments. But in your own words, could you introduce yourself and talk a bit about your work with patients with autoimmune conditions in general, and with this podcast in mind, MS in particular?
Right. So I'm a professor and I'm a physician, an MD, and I'm a pioneer in the use of stem cells for autoimmune diseases. I'm really known for my work in hematopoietic stem cell transplant, that is using the blood stem cell. Hematopoietic means blood. But I also have been working steadily with IPS, and we have certain patents in that. And in the future, hopefully, if time allows, we'll be developing some induced pluripotent stem cell or IPS therapies as well. But the therapies that we have done and we've published and we offer for patients now, and that I've helped teach universities around the world how to do, and they have trials now to do it, is hematopoietic stem cell transplant for autoimmune diseases. And that was an idea that occurred to me about 35 years ago. I was a young fellow at Johns Hopkins, and they were re-immunizing patients for all their childhood vaccines after a stem cell, blood or hematopoietic stem cell transplant for cancers. And the reason they were doing that is they lost their memory immune cells, their memory response to those vaccines. And so it occurred to me that's exactly what you want to try in an autoimmune disease. And I said that to my professor at the time because I was a fellow. I said, "You're re-immunizing these patients." He didn't respond. I said, "That means they lost their memory response to those peptides, those little proteins." He didn't respond. He wasn't being rude. It was just really busy clinic. And then I said, "That means we could use this technique for autoimmune diseases." And he stopped, looked up at me, eyes appearing above his glasses, and said, "You're right. We could do this for multiple sclerosis." So that's how it started. And then it began 10 years of preclinical animal work in animal models of autoimmune diseases, including MS. And when I first started it, I didn't even know there were animal models for MS, but there are. And after learning and how it works in those systems and studying the immune system with that approach, we eventually were able, or I was able to get approval to do it in patients. And so that eventually led to phase 1, phase 2, phase 3 trials. Phase 1 is just a small trial for safety. Phase 2 is more larger number of patients for efficacy. And phase 3 is where you compare it to what's out there. That is a disease-modifying therapy. And along the way, we had to learn how to tweak the trial, the conditioning regimen used to make it most optimal, learn the best type of patients that respond to this. And then in the randomized trial, it was just hands down much better than any drug. So, all the drugs you use for MS, they're based on approval for slowing disease activity. That is, slowing the number of relapses or slowing the rate of progression of disability, but not stopping it or not reversing it. Whereas, and often you stay on these drugs, so kind of indefinitely. So, transplant, on the other hand, it was a one-time treatment, and afterwards you got nothing and you got better. Your neurologic disability reversed. Nothing else had done that. And you didn't need any more treatment. And we reported results up to 5 years. And importantly, quality of life improved, which doesn't happen on these drugs. And the reason it doesn't happen on the drugs people take for MS is it doesn't reverse the disease. It just slows progression, and then you're having to deal with the side effects of the drugs and taking them and inconveniences and money, time, expense involved in that. So quality of life doesn't improve. Whereas after transplant, you're drug-free and you get better. And most people, the majority, stay improved. So I knew that the majority, about 75 to 78%, did not relapse by 5 years. But most recently, I wanted to get this information out to the lay public because a lot of people still don't know this. I mean, this is a hard-fought work over decades, and it fundamentally changes this disease from a chronic process to a one-time reversible illness. And so, but people don't know. So I wrote a book, Everyday Miracles, and that's how this interview came about. And this is the book that you can get on Amazon. It's available, and it's written for the lay person. And if I use a bigger word or medical term, I explain it. But I think medical people will also enjoy this. Anybody in the medical field, anybody with MS, anybody with autoimmune disease, or just any person, I think, would really enjoy this book. It gives you a look inside these diseases and what it does to people in this therapy and what happens to them after that treatment. In fact, this book, I almost called it a Profiles in Courage, because it's stories of patients and what MS was doing to them on these drugs, and then what happened to them after transplant. And, it's really, I think, uplifting to see the courage, the determination of the human spirit when they're told they have a chronic disease that they're never going to get better from. They're just slowly getting worse. And how they fight and keep looking for an answer, how they have to, or the victim of domestic abuse by their own immune system against their own body, and then how transplant turns this around, because it resets the immune system to a new immune system tolerant to self. And so in writing this book, I started contacting patients I'd done 20, 15, 10 years ago, just randomly for their stories. And I found out, my gosh, they're still in remission. No drugs, got better, stayed better, having great lives, most of them. Some still have some permanent deficits because that some damage, can no longer be reversed. It's stunning if you get them right that you can still reverse damage and not just stop inflammation and stop attack on the immune system, but actually on the neural system, the central nervous system, not immune system, the attack by the immune system on the central nervous system, then you can stop it, but that can actually repair itself to some extent. And so I was surprised that every single one I contacted was still in remission. And obviously people are glad to be free of the medical system and, no particular interest, come back, get another MRI and go through a big exam and all that. But they're doing so well, I thought, as I should, if I ever find the time, systematically make a report of everybody beyond 10 years and how they're doing. Because we know now that most of the relapses do occur within the first 5 years, and that by 5 years, 75 to 78% remain in remission without ever having a relapse, ever needing new drugs. and that it seems like the majority after that stay in remission. Because we always tell people to contact us if they have a relapse. I only had one contact after 5 years. That was about 11 years out. So just randomly calling and found out, wow, they're still doing great. And so some of their stories are in here. And the main reason for doing this is that despite all my talks in medical publications and writing medical textbooks, a lot of physicians don't know this and a lot of patients don't. So I wanted to empower the patient so they could read it. They could go to their local physician, say, what about this? And of course, a physician could look at that and say, well, that's a lay book. That's probably science fiction. It's not. It's not fiction. And so 1 year ago, in November of 2021, I came out. I was the senior editor on this textbook, ton of work. Rewriting chapters, working with authors, writing my own. And it's 686 pages and 140 professors and associate professors from around the world, including England and Europe, mainland Europe, China, Australia.
And could you give us the name of that one for people who are just listening?
Yeah, so this book is called Hematopoietic Stem Cell Transplantation and Cellular Therapies for Autoimmune Disease. It's also on Amazon. It's a medical textbook, so unfortunately it's expensive compared to a lay book. Mm-hmm. And it's designed for physicians and researchers in the field, so most people may find it a little boring that are not doing this type of research or who are not working with these kind of patients or who are not directly doing cellular therapies. But I've often found a lot of my patients have spent a lot of time reading and studying and figuring out these diseases, and they know a lot. And I think they'll glean information out of those chapters for their given diseases as well.
And so, are you aware of Gavin Giovannoni in the UK?
Gavin, yes, he's at Bart's, isn't he?
Yes.
So
he's very much at the moment talking about what he calls flipping the pyramid, where traditionally we would go with an approach where you start with the mildest form of disease-modifying therapy, and then as you get worse, you move up to something more efficacious, and eventually you might well have lost complete mobility before you're offered something like HSCT. And what he's saying now is actually, why are we not offering as the first line of defense immediately upon diagnosis? Why are we not offering HSCT or alemtuzumab? He said one of those two things should be offered to everyone as their first, at least as a choice. They should be given the choice to say, not starting you with something very mild and very, there's lower side effects, but also they're not as strong drugs, and you will have progression, and then ultimately some people are absolutely fine, of course, but then equally a lot of people are accumulating disability before they're offered the strongest treatments. Is that something you agree with? It actually should be flipping it and saying, actually, this should be offered first, not last.
Yes, I mean, I definitely have listened to his lectures, been in the audience. He's listened to my lectures. I do like the way he thinks. I do like the way he's trying to adjust the thinking in the field of neurology. And certainly one of the concepts that has been missed, I think, in the field in terms of this disease is the concept of brain atrophy. We all know in a heart attack that time is cardiac tissue and you have to work fast to save the heart. It's viewed as an emergency. On the other hand, MS causes an accelerated loss of brain volume, that is brain atrophy. Now, unfortunately, as we age, we get brain atrophy at a normal, very low, but normal decline. But once you get MS, that decline takes a much sharper drop. And so you're losing neural function a lot faster than normal aging. And for some reason, that's not viewed as a sub-acute or semi-emergency situation that you want to reverse. The traditional drugs have mostly just kind of slowed that rate of decline, but it's still faster than what happens with normal aging. So I would think a more aggressive approach up front would be wise, but you always have to remember risk benefit. And, if we could do a stem cell transplant with zero risk mortality, I would say absolutely for everybody. But you can't do that right now. The lowest mortality for the procedure is 0.5%. In my own hands, and we published the results of 507 patients in Journal of Neurology, I think about a year ago, and the mortality was 0.5%. So, you never want anyone to die from your treatment. Of course, I think you give all the options to the patients and let them make that decision, but you want it as safe as possible. But obviously, there are some types of MS that are so benign and so slow and never really get to progressive form that I would not offer this to. Mm-hmm. On the other hand, the vast majority of patients with MS have been undertreated and have been allowed to get into progressive neurodegeneration, which is no longer an immune-mediated immunologic attack on the brain, but a neurodegenerative disease for which nothing works, including hematopoietic stem cell transplant. So you don't want the patients to get there. You don't want this undertreatment that has been going on in the medical community for this disease. So it's refreshing for me to hear a neurologist speak as Professor Gavin does at Bart's.
And so I think we've covered the benefits. And so you say that the primary risk of HSCT is essentially like a 1 in 200 risk of fatality. And other than that, is there other risks?
Well, it's about 1 in 500.
1 in 500. Sorry, I was at 0.5%.
You have to remember, now here's another big caveat. When we talk about disease-modifying therapy, there's all these drugs out there, 13, 14 drugs. There seems to be a new drug appearing all the time. But, And that's good because all drugs have different side effects. And, if one's not working, the physician can change to another. They just have more tools in their armamentarium to treat the disease. But when you talk about toxicity and efficacy, you have to be disease-specific. For instance, there's one drug that's very high risk compared to all the others of giving a brain infection with a virus called JC virus, and that gives progressive multifocal leukoencephalopathy, which, if it doesn't kill you, leaves you much worse off. So you definitely don't want that. But the drug that can do that is natalizumab, also known as Tysabri. It's occurred with some of the other drugs, but nowhere near the rate of natalizumab. So when you use natalizumab, you need to check if a patient is JC virus positive. Most are, and then you need to follow the index. And if it's rising, you need to stop the drug before they get PML. You don't need to do that when you're on Gilenya or Copaxone or anything like that, but you definitely do when you're on natalizumab. And the problem with HSCT, people think it's this one thing out here. You've got all these drugs and you got HSCT. No. HSCT, their toxicities and their efficacies vary, not only by patient selection, but by most importantly, the regimen you use, which is about 5 days of a conditioning regimen to knock down your immune system and then allow the stem cells to regenerate a new one. And that regimen you use, it determines the toxicity, both early and late. And so it's very much regimen specific what you have to worry about in terms of toxicity. So don't think of HSCT as one entity. There's different ones and within HSCT, there's 2 big subdivisions. One's myeloablative, the other's non-myeloablative. Myeloablative means if you don't give the stem cells that you collect from the blood or bone marrow, but bone marrow is the way it was done in the old days. Now we get them out of the blood. We get the bone marrow stem cell or the blood stem cell out of the blood these days, not out of the bone marrow. Initially, it was out of the bone marrow. So it's often called bone marrow transplant, but that's not done very often. It's peripheral blood transplant now. But in any event, when you do myeloablative regimen, which are used in cancer, if you don't give those stem cells back, the patient's going to die. Because the stem cells in the bone marrow are all killed, and you can't live without the bone marrow making cells. Because it not only makes your immune cells that fight infection, it makes red blood cells carry oxygen, makes platelets that clot bloods, and you just up and die without those things. So you have to give the stem cells back to allow that recovery. On a non-myeloablative, you don't have to give them back because the stem cell compartment is not damaged by the drugs you give. Only the immune cells are. So it's more focused to the cells causing the problem. But if you give them back in a non-myeloablative, you shorten the period of neutropenia and of needing blood transfusions by about 4 days. So anything that shortens being in the hospital or shortens the risk when you could get an infection because you don't have a good number of cells to fight them, or have a serious bleed because your platelets of clot blood are too low or red blood cells too low, whatever. Anything that shortens that, that's good. And that's why they're given. But if you don't give them, you're still going to recover just fine, but about 4 days longer. So that's the big difference within transplant itself, myeloablative, non-myeloablative. Then within those, there are different regimens being used with different toxicities. For instance, you can make a non-myeloablative more immune ablative than any myeloablative regimen out there, but still immune specific, won't damage the stem cell compartment. So the details are important, and it kind of goes beyond, I think, the audience listening to this, except to know there are different types of transplants, and that one way of breaking them down, an important first breakdown, is whether they're myeloablative, that is cancer regimens, or non-myeloablative, which are immune specific for the immune system. I've always been an advocate for non-myeloablative. Don't use those myeloablative cancer regimens. They're much more toxic. They're much more expensive, about twice as expensive for an expensive procedure to begin with. In America, now the costs in Britain are totally different than in America, because in the National Health Service, they don't include the cost of the room in the hospital and security guard.
We don't have in the UK. It wouldn't cost you anything. It would be completely free. But if you are offered it,
yes,
this is the thing. So it's yes. If it's available to you, then it's free. And
right.
If it's not, then it could be very expensive.
So in other words, a transplant in America, but non-myeloablative, the way I do it's $100,000. In the UK, it was about 40,000. That I was like, why is that? And then I realized it's because I've written a paper on that, and I did it with people with a university in England. And it's because in their system, they're only counting the drugs and the nursing and the physicians. They're not counting the infrastructure, because that's paid for by the National Health Service, and they don't have access to that budget. So they don't count that. But in America, all that has to be paid for out of the cost that the patient or insurance pays. So the prices are really the same. It's just the bookkeeping is different. But in the NHS, somebody's still paying for it. Taxpayers are paying for it.
Yeah.
So, it's just the way the accounting done is different. Mm-hmm. But so the costs are about the same. It's really $100,000 overall, society, patient insurance, whatever. However, the bookkeeping is done. It's different in America than in the UK. But a myeloablative regimen is about $250,000. So it's more than double the cost, and it's more toxic. And I don't believe they're, in fact, any better. Now, you can't prove what I'm saying without doing a randomized trial between the two of them, but nobody's going to do it. I certainly wouldn't, because our results are so good with the less toxic regimen that I don't want to use the more toxic regimens designed for cancer. Mm-hmm. And again, the reason they're designed for cancer is you want to kill the leukemic, the malignant stem cell. In autoimmune disease, your stem cell is not bad. It differentiates into immune cells that become misdirected later in life and become aberrant or bad. Now, there's a rare exception. There's certain childhood immune diseases that are a genetic defect of the stem cell, and you'd have to do an allogeneic transplant for them, not autologous, but those are rare. And in fact, in the medical textbook, we have a chapter on those genetic immune diseases that are almost always picked up in children. But that's not what the large number of autoimmune diseases are, especially in adults like MS. They're not pre-programmed to occur due to a monogenetic abnormality. There's probably an impact of multiple genes and environment and hormones that trip your immune system, but it's not purely genetic. And it can be reset with an autologous transplant, and there is no need to destroy the stem cell compartment like you do in cancer. There's no rationale to do it, in fact. The stem cells are not bad.
So you've mentioned about the ability to have the right patients. So you said that you need to have people who are in the relapsing phase of MS. Are there other caveats that you'd say that people who make a good candidate for HSCT? Is it younger people or fitter people, or is it fairly broad within that spectrum?
Well, I would say younger people do better than older. I think that's pretty much true with any type of therapy. And it's true in transplant. But the key is that they're relapsing remitting. And again, if you just have one attack every 10 years and you're walking around, you're fine. I wouldn't do this. Risk benefit's not there for it. So back to your question about doing it for everybody, no. But the people we look for are people who have, at diagnosis, so much activity of MS in the brain at onset that a neurologist would want to start one of these more potent immunosuppressive drugs like cladribine or Lemtrada or Ocrevus. That's a group I would take to transplant up front. Otherwise, I would take people who were started on a first-generation DMT like Copaxone and interferon who are having 2 attacks or more in the last year, or a group that's on a second or third generation DMT like Gilenya, Tecfidera, or even Ocrevus or whatever, who or natalizumab, who have 1 attack within the last year despite being on those drugs. And those are the people with relapsing remitting who do very well, and they do well independent of age. The oldest we did was age 58, and that person did well with improvement. But I think the younger you are, the better. And it's just the body's able to recover faster. So now, I wouldn't do secondary progressive. That's a neurodegenerative process. But again, the caveat is you're not one day relapsing remitting and the next day secondary progressive. There's a gradual transition of usually over years, and you don't know when it really occurred. When you're there, you know it's secondary progressive, but you don't know when it really happened. And you could see a patient every month for 2 years and not know what happened, then all of a sudden look back to your note 2 years ago and this is secondary progressive. So what happens in that gradual transition, secondary progressive means that your baseline, your neurologic baseline is declining, you're getting worse, but it doesn't correlate with any new attacks on the brain. No lesions, no new acute attacks. But there's a transition period where you have active secondary progressive, where you're progressing between it, getting worse, declining between acute attacks, but you still occasionally have an acute attack. So active secondary progressive is a new MRI lesion enhancement or new acute attack within the last year, despite being secondary progressive. That group can still benefit from this, not as much. So instead of like a 1 to 1.5 improvement in EDSS, which is how you measure neurologic dysfunction or neurologic ability, it's 0 to 10. That's a scale. 10 is dead, 0 is normal. So it gets better by 1 to 1.5 points. With active secondary progressive, it gets better by 0.5, half a point, but at least still gets better. Once you're non-active, no, it doesn't help you anymore. Now, the argument could be made, well, maybe you plateau out, but, I think once you're in non-active secondary progressive, you really need to be looking at a whole different approach, not an approach that resets the immune system, because it's no longer immune mediated, it's neurodegenerative. Now what you need is a true neurodegenerative therapy of some kind, or, for instance, a neuroregenerative stem cell type of therapies that currently don't exist. So we don't take non-active or late secondary progressive patients to this procedure. And if you have relapse remitting, but it's fairly mild and you don't have many attacks, and you're not having severe attacks, it's very infrequent, I wouldn't do it. I think the risk benefit justifies it. But I think definitely there's a large group of patients with relapse remitting, which is 90% of patients at diagnosis, that would benefit from this being offered much sooner than what it is currently being offered. Now, why isn't it being offered sooner? And it's not that physicians or neurologists don't want the best for the patient. They all do. They're all very hardworking. They're all very intelligent, and they all have a ton of experience. The difference is that it's the way medicine has gotten set up. And I go into that in the last chapter of my book, and we won't have enough time to go into all of those, why that is. It's not that any one particular person or group of people is malevolent. Absolutely not. It's the structure of medicine that has directed us down certain silos. So, for instance, neurologists do not understand what stem cell transplant is, hematopoietic. To them, it's just these awful cancer regimens and the suffering of a cancer patient. They don't do it. They don't live it. They don't see it. It's kind of like, what is it, that movie, Avatar, where, they said, I see you, meaning you understand each other. They don't see it because they don't live it at all. And, so to them, they're not going to refer patients to it. unless they're late secondary progressive when it's not going to work. The hematologists that do transplant don't understand MS. Even the difference between a myeloablative and a non-myeloablative and the rationale for it, they don't, because they use, there's no such thing as a non-myeloablative autologous transplant for cancer. They're all myeloablative for autologous cancer. So they don't understand the disease, and they haven't subspecialized in it. And so I think that's the big hindrance to why this isn't going forward. There are others, and they're listed in the book, but what made me accomplish it and to be able to understand it is that as you mentioned, I was Leukemia Scholar of America, but I had this idea to do, I got that because of a gene therapy study I did in leukemia, but I got this idea to do this in autoimmune diseases 35 years ago. And I started working in animal models on it. I found that it would work. I learned a lot about the immune system. So I totally shifted my focus. I stopped doing leukemia and cancer totally, and I focused on autoimmune disease back before anybody had ever done that. Now, that's a risky move. You could end up, unemployed.
Yeah, well, if it didn't work at all,
you're doing something nobody's ever done. There's no path to follow, whatever. But I did it, and by doing that, by focusing on that, by giving up cancer, I became really good at what I did and was able to accomplish a lot and see this field expand.
So do you see a future where there's actually autoimmunologists who cross the more traditional, if you like, hematologist and neurologist, and that they actually will understand the whole picture?
Yeah, well, so I think that's one of the key reasons I was able to cross that field, because I focused on it. And I think a lot of people think you should kind of be good at everything, but the truth is, kind of one of the little secrets I think out there, if you really want to be good at something, you have to really subspecialize and take that risk. Like Federal Express became very good, world famous, but they focused on only delivering packages. Mm-hmm. They didn't compete with the U.S. Post Office on envelopes or letters. They focused on just packages. Subway sandwiches focused on just making Subway sandwiches. Kind of a crazy idea, but they have stores around the world. Pizza Hut started one little guy out of college, stopped going to classes, started making pizza. They focused on one thing, making pizzas. And then they spread around the world. So when you do focus on one thing like that, you get really good. If you don't, you get pulled in other directions. But in any event, I call that in the book homeless. So one of the ways around that homelessness is you can take someone that knows transplant and they focus on just MS, say, or just autoimmune diseases. But even then, there's so many of those, and I mentioned 5 of them in the book, and they're different, and you have to understand each one differently, that you'd have to focus on just a few. Or you take a neurologist and you focus just on transplant for MS. Very few people will do that. Very, very few. They have families to feed. They see that as a risky proposition up front. So I think, a few will, though, as time more and more probably will, because it does work and patients are going to demand it. And that's the difference. But as in the book, I say, I'm kind of homeless, and this is a homeless field. And one of the ways around that is through national directives. In America, there is no National Institute of Autoimmune Diseases. Never has been. There's a National Cancer Institute for cancer, and it funds cancer centers all around the country, and it focuses people in cancer. But there's no National Institute of Autoimmune Diseases that would fund autoimmune institutes around the country in which stem cell transplant and other types of cellular therapies, and believe me, other types of cellular therapies can also be involved in treating patients with autoimmune diseases, whether they're neurostem cells, IPS, induced pluripotent stem cells like I also work in, or CAR T cells, or mesenchymal stem cells, or whatever. There's going to be other types of cellular therapy. So if you had these National Institutes of Autoimmune Disease centers that funded through NIH or through the National Health Service in England for centers of excellence, just like you have in cancer, but that they included a department or division of stem cell transplant or cellular therapies, this would really take off. And so there's 80 different autoimmune diseases that I can think of offhand. I have a table in the book of 75 of these different diseases. They're all, homeless in different departments, like Crohn's disease that I talk about transplant in here. That's in gastroenterology. Scleroderma is in rheumatology. And multiple sclerosis is in neurology. They're all separated out in different areas. So, if there was a better organization, beginning at a federal level with the National Institute of Autoimmune Diseases that supports centers of excellence around the country, that would really help this go forward. Short of that, I have no power over legislative bodies anywhere, much less in Washington, D.C. But, maybe they'll read this book and start getting some ideas. But the short of that, it's going to take physicians making that crossover and someone who knows transplant focusing in on one or two or a few autoimmune diseases and making a career out of it. And believe me, they'll make a good academic career with a lot of publications because they'll become experts in doing it just like I did. And so that's kind of where it's going right now. But there are other ways to accomplish this, but that would require kind of a restructuring of medicine. And the reason it arose this way is that medicine arose by people specializing on what they could see. So if you saw the skin, you really wanted to work on that, you became a dermatologist, the eyes, ophthalmologist. And in autopsies, we saw the heart, and it was figured out how circulation works. That was no small feat, but then you became cardiologists. You became pulmonologists, lung doctors, hepatologists, liver doctors. You could see these organs, but for the longest time, nobody had a microscope and nobody could see these cells in the blood. And then once they got them, they didn't know what these cells did. That was eventually sorted out. And by the time that happened, there rose departments of immunology that did the basic research on these immune cells. But they didn't treat any patients because the treatment of patients was already orphaned off into all these different departments, depending on organ involved. So MS ended up with neurology. So there was never an immune treatment institute. So there are basically two ways around this. One, you start national funding, centers of excellence for institutes of autoimmune disease. The other is that people who do who know how to do transplants, give up doing cancers, give up thinking myeloablative, learn these diseases, MS, neuromyelitis optica, Scleroderma, Crohn's, whatever, learn these diseases and read the literature of what's already been accomplished and who, it's already well defined in some of these diseases, the optimal patients to select and optimal regimens, and then start doing it. And there's, many, many more autoimmune diseases that individuals could focus on and perfect this therapy and bring it to the bedside. So it's going to be up to really, I think, young physicians that are willing to take that initial leap forward to focus a little bit untraditionally to offer this great therapy. By patients driving it bottom up, that'll happen. They'll push doctors to do that. And it'll initially probably be a doctor that does leukemia or transplants or lymphoma transplants who starts doing MS and then realizes, wow, his whole career can be tied up just doing MS. He'll focus on it and become very much of an expert. So that's kind of, I think, the way it's heading, short of changes in directives at the national levels from governments.
If we've got individuals who are listening to this who think, well, that is perfect for me, they completely fit within what we were saying, they're relapse remitting, they're young, they've got active MS, and they're interested in this, okay, what would they look for in a clinic or a physician to give them more information and to take it further in looking to get HSCT?
I set up an educational website as well. I'd recommend get this book and read it. And you'll
that's Everyday Miracles, if people are listening.
Yeah, by Richard Burt, B-R-T. By the way, the foreword is by the Dalai Lama, which I was very blessed to have that. I also set up a website. It's called astemcelljourney.com. So www.astemcelljourney.com. Lots of information there, tons of information. All my publications are there. You can download them, read them. I don't put anybody else's there. That wouldn't be appropriate, but mine are there as well as talks and rationale and many things.
And we'll put links in the show notes as well. So if anyone's checks the show notes.
You look at what centers are doing this in America. I do it at Scripps in La Jolla, California, and you can contact us there and we'll start the process of a nurse contacting you for intake forms evaluation to get the necessary information. Because if it's clear that you're not a candidate, you're late secondary progressive, we'll just screen you out so you don't have to waste time or money to fly there to be evaluated. So, or, in the UK, they've now started a protocol called STAR MS, which offers transplants versus one of these aggressive new MS drugs. I think, cladribine or Lemtrada or ocrelizumab or something like that versus transplant. So that's ongoing in the UK right now. It's a trial. You get randomized to one or the other. At my center, because we already completed a randomized trial and transplant was markedly superior, we're offering still a randomized trial, but 2 types of transplant, the way I've always done it versus a way that's, I think, even safer. And if we get this same long-term benefit, it would be cheaper, and it would be safe enough for us to do it as an outpatient. So you don't even need to be in the hospital, which would then markedly cut the cost. Because most of the cost is the overhead of being in a hospital. What you don't see in the UK, because those costs are hidden, paid for by the National Health Service, but in America, insurance has to pay for it, is a hospital room is like $2,000 a day. I mean, it's crazy. You could have a great hotel suite for that, and that's certainly not what you get, but that's what they cost because of the expense and overhead, the bureaucratic red tape and all the stuff they have to do and documentation and oversight and stuff. That's just the room. You put an IV in, bring an IV pull in there, it's another $200 a day. Every IV bag is like another $500 a day. It gets really expensive. So, if we can do it as an outpatient, it'll markedly undercut the cost even more. And so that's what I'm comparing the way I've always done it to another non-myeloablative regimen that I know it's going to work upfront. Will it give us good long-term results? If it does, it'll be cheaper. It'll allow us to do this as an outpatient, which not only is it just cheaper being done in-house, less expensive, it'll be even much cheaper because it can be done as an outpatient.
But even if you're talking about the, let's say, $100,000 that you mentioned before, even at that level, would you say, because I'm aware that, I've gone through starting with Tecfidera and then ultimately had Lemtrada infusions. And I'm aware that actually the Lemtrada was expensive, but ultimately may well have been cheaper than the Tecfidera in the long run, because that I was going to take for the rest of my life, which hopefully was going to be a long time. So how does it compare when you say, actually, well, $100,000 once, how does that compare to someone who's they're in their 30s?
Perfect question.
They're going to live a long time.
Yeah. So I actually put in the book a table of the cost of all these drugs when they first hit the market, like the interference Copaxone first hit the market in 1994, and the 2020 costs. So when they hit the market, they were $9,000 a year or $12,000 a year. In 2020, they were $100,000 a year. So what happened, I listed a table of 14 drugs and what their initial cost was when they were first FDA approved that year, and then what they are in 2020. And I'm sure they're much more now, but because they hyper accelerate much faster than the rate of inflation in their charges. And what happened is a new drug comes out, it's more expensive because cost of development and regulation, everything's much more expensive. The old drugs just match the price of the new one. And so they all of them, around $100,000 a year, which is the cost of one transplant, but transplant's a one-time thing. So, if you start looking at this over 5 years where 75% don't relapse, need any new drugs, you're saving $400,000 per in 3/4 of those patients over that 5-year interval. It's a big cost savings to society and insurance. But people don't recognize that. One of the reasons they don't is another problem I bring up at the last chapter, and I title it Financial Toxicity. And that is, physicians are not aware of the cost of things. Your physicians in the UK are not, because they're employees of a public system. In America, most of them aren't, because you're not taught it. Your publications, whether it's Lancet or New England Journal or whatever, they never list cost effectiveness or the cost of this stuff. You don't know what it is. And unfortunately, in America, more and more physicians are becoming employees of hospitals or institutions, and the bureaucracy and the business people above push them to bill more and more and more. That's called RVUs, and they expect you to do so many for the salary you're getting, and if you don't achieve that, you're penalized because they don't feel they're getting their value out of you. If you get above that, you're given a kickback of some money at the end of the year, which for like, I've seen it in our own institution, surgeons get more back at the end of the year than I would make all year, by much more, because they look at the RVUs, they give them back. But that's incentivizing people just to bill and not understand what those costs are, or if there's something that's equally or more effective, but cheaper.
Yeah. It's not incentivizing people to actually make them well, is it? Really?
Physicians are not taught to think that way. And I call that financial toxicity. It's like if you go to get your car fixed and the dealer, you just need spark plugs, quick tune-up spark plugs. You come back and you got new brakes, you got new hydraulics, you got new tires. The spark plugs, they were built by some company for Lamborghini in Italy, and they're $1,000 each. You're not going to pay for it. You're saying, what is this? I wanted some $50, $25 spark plug. But medicine doesn't work that way, and you don't have a say in it. And doctors aren't aware of the cost. They have no idea. So what happens is we are trained to think about the best medical care, or, and then secondly, not as well trained, but think about the psychological care of the patient. But medical care and psychological care fail if financial toxicity is there and the patients can't afford it, or the society can't afford it. Because what happens in a system like England, when they can't afford something, they think it's too expensive, they won't approve it. And they often look at the upfront expense, not the expense over a long period of time. So, if we are publications, you go phase 1, phase 2, phase 3. Phase 3 is the randomized. Okay, that means it's great, go forward for anybody. But there's never a phase 4 where you look at cost effectiveness, what you're doing against everything else out there. Cost effective means not only the cost, but effectiveness turns to outcome and duration of outcome. So when you look at transplant, it's a one-time thing, and then you don't need anything for the rest of them. It's markedly cost effective, but it's not compared to all these drugs that are the same cost every year over and over and over. But people don't think that way because they're not taught that way. And so if physicians are taught that they need to be a physician, not just medically, but financially for their patients, it would markedly change this out of control acceleration costs for medical care. By doing that, then you're allowed to give more medical care to more people. So I call it, what we want to achieve is advanced, affordable, accountable, and all-inclusive. Those are the 4 A's everybody should think about, legislative people, when it comes to medical care. But those principles compete against each other. Sometimes if everything's all-inclusive, everybody gets it, it's not going to be the most advanced because it's too expensive. So by letting physicians have the power to direct the best care, but also when you're looking at it, it's more affordable, you're putting a checks and balance of cost on the systems and getting it made affordable at the bedside for that patient, for that physician, who are the group that really knows. So it's empowering the physicians, giving them the ability to understand costs, and then by getting patients the most cost-effective therapy, they'll get more patients coming to them, which will be their reward, where they'll benefit more. Unfortunately, our system, whether your employer is a government or a hospital, isn't structured for that. And that's why these medical costs are so out of control. And then that's why they're limited, so they're not all-inclusive. We want medical care to be all-inclusive. Everybody should be able to get everything. We want it to be very advanced. Well, that makes it expensive. Initial research and everything is expensive, and that's got to be offset by something. And then, of course, we want it to be affordable. We want it to be accountable. You have a person, not an institution or a system or a government, because they're not accountable. They're not to a person. So you need a physician that represents you. It's like if you go to a courtroom, if your lawyer is an employee of the judge, you're not going to feel very good about him representing you. If your lawyer is an employee of the prosecuting attorney who's prosecuting you, you're not going to feel you got good representation. So when a physician is an employee of the government or a private hospital or a private company, they have to have loyalties and follow what they're told by the system, which is functioning to feed itself. What you need is a system that's patient-centric, that protects that one patient. And a physician can do that if he's an independent physician. And that's because medicine is a profession, but healthcare is a business. And this business aspect, physicians have not been taught or even think about taking control of, but they should, because that will make medicine more affordable and more accountable, and with more money available, more all-inclusive. And so you can say, well, in some government systems, it's more all-inclusive than in America. But then I've seen time and time again in those government-run healthcare systems where it's limited. So
that's the point. So coming from the opposite side, so from the NHS system in the UK, that what we get is free at point of use, which is fantastic. So I haven't had to have any insurance to have alemtuzumab. I didn't pay any money for it. The hospital stay was paid for, everything. But we have a limited choice because we only have what's been signed off by the central board as effective. So things like simple things like medical marijuana, very, very hard to get it in the UK, which I've spoken to people in America. They find it extraordinary. They go, well, hang on, but you've got MS. Surely you can get medical marijuana. Sure. Here, no, you can't, because they've decided that it's it's not approved. So although if we were in Scotland, it would be. But in England, it's not. It's very bizarre that you get these some place you can, some place you can't. And
yeah, absolutely. So what I hope is that people read this, and people who write legislation read this and understand that, how do you, healthcare is so complex and so large. How do you make constructive change? Because there's repercussions that are unwanted whenever you tweak on one string. They're all interconnected. But, again, it's the 4 A's: advanced, accountable, affordable, all-inclusive. But those are competing demands. And the way you do that is you put checks and balances where they can check and balance each other. One big way to do that has never been done is demand that these publications have a final phase 4 with cost-effective analysis. And then the physicians understand the cost of what they're making a patient or insurance or society pay, and the effectiveness of it for that cost. So that, for instance, just quality of life. All these DMTs have never been shown to improve quality of life. Transplant does. Now, some of the newer ones, they have a numerical improvement in quality of life by 1 or 2 points. So they say that's improvement. But that's meaningless, because to an individual patient, an improvement in quality of life in the SF-36 must be a minimum of 5 points for them to feel it. So it's statistical improvement, but clinically meaningless improvement. Mm-hmm. Whereas in transplant, it's 15 to 25 points. So it's a very clinically meaningful improvement. Obviously, if your neurologic get better, you get off drugs and all their expense, cost and time and side effects, of course, quality of life improves. So you need that final on everything: quality of life and cost effectiveness. And then in physicians who are not handicapped by being employees that have to function to feed that system above, because they're the money revenue generators for the system above, but who can then function to represent their patient. And in the UK, okay, the money revenue is coming from the public health system, but they're being controlled by that public health system and administrators who are totally distant from a lumbering bureaucracy that doesn't know and is not involved and can't change on a dime for the patient sitting in front of them. Mm-hmm. But if they know, and they can, if the physicians are independent professionals, medicine is a profession. If they're independent, then they could direct to make sure it's the most cost-effective therapy. And that's what's been missing in medicine. So, I accomplished this. And patients would say, who've done this, I don't understand. Why aren't institution people screaming at rooftops that people get this? It's because of the way the system's gotten structured. And one of them is financial toxicity. And so, by making these subtle changes, things like this would be a lot, they would come to patients sooner and they'd be offered a lot faster.
So to wrap up, this has been quite a long episode now. Firstly, I think everyone would agree there definitely could be improvements in the way that healthcare is structured, regardless of whether that's in a system like the US, a system like the UK, or the many systems in between the two. And I think I absolutely agree with what you were saying. It's critical. And who knows, there could be changes. I mean, there has been Michelle Obama's mother, I believe, had MS. Mitt Romney's wife, I think, has MS. So, maybe there's some, politicians might get more involved if it's closer to home. But the other thing I would say, actually, the other big thing, obviously, we covered is HSCT. So I'd absolutely encourage people to have a look. In the show notes, we've got links to your book. A layman's, because I think a lot of it is technical. I search a lot on the internet, but a lot of it is difficult to understand from someone who's not got a specialist background. But yeah, layman's guide to that would be absolutely beneficial. And so yeah, have a look for that. But I want to finish up. You mentioned the Dalai Lama, because the Dalai Lama, of all people, did the intro to your book, Everyday Miracles. And the Dalai Lama very much promotes mindfulness, meditation, and this is one of the programs of the Overcoming MS approach. So using stress relief techniques like mindfulness, meditation. Do you see that there's an intersection between that mindful aspect and medicine?
So this book is about transplant and patients go through it and their diseases. It's not about meditation per se or mindful meditation. It's just not about that. I was very blessed that the Dalai Lama wrote the foreword. I am not in any way qualified to speak for him. It was just a blessing given to me.
So how did that come about, though?
As I say, I'm not qualified to speak for him. It was just a blessing.
Okay, brilliant.
Yeah. So, but finally, I'm working in IPS in animal models. We've developed real neuroregenerative potential, and we're working to try to get that. We have 7 patents on our IPS work. We started a little biotech company, and I'm trying to get those to the patient's bedside. It'd be simple. It's not for stopping an immune attack like HSCT does. It's for these late neuroregenerative or just neurodegenerative processes, and as well as actually repairing any organ or age system.
And so could this be something
that we're working on? And it's simple. It's just injection of the cells. But it's a whole different set of hurdles that we have to get through, and we're working to get there.
And that could be for something for people with progressive MS as well.
Absolutely. And
Brilliant.
That maybe someday will be edition 2 of this book.
Fantastic.
God willing, and I live long enough, and it's a whole different set of hurdles. It keeps you young. But again, if these things were easy, everybody would do it. So it's a lot of things we've got to accomplish, but we're working on it.
And with
patents, we want to go to clinical trials. It's now getting over those hurdles to get there.
Mm-hmm. With that, thank you very much for joining us, Professor Richard Burt.
Thank you so much.
Thank you for listening to this episode of Living Well with MS. Please check out this episode's show notes at overcomingms.org/podcast. You'll find useful links and bonus information there. Have questions or ideas to share? Email us at podcast@overcomingms.org, or you can reach out to Jeff on Twitter @JeffAlex. We'd love to hear from you. Thanks again for tuning in, and see you next time for tips on living a full and happy life with MS. The Living Well with MS podcast is for private, non-commercial use and exists to educate and inspire our community of listeners. We do not offer medical advice. For medical advice, please contact your doctor or other licensed healthcare professional.